In previous videos we learned how to make a symmetrical bicycle seat by making one half, mirroring it to the other side, cutting a slot out of the middle, and then making a boundary which bridges smoothly between the two. At this point it's probably occurred to you that this is a lot of work and that maybe the right solution is not to build one half of the seat when making the boundary, but make both halves of the seat at the same time. So instead of having profile sketches that end right on the front plane and then are mirrored over after making the boundary, just have the profile sketches include both halves of the seat. And in fact we can do that, as you see here, and each profile includes both the left and right half of the seat, and this produces a nice seamless looking construction which is completely symmetrical and satisfies all of our needs. So why not just do it this way? So let's take a look at the starter file you've been given. Before you were given only one half of the profile in each sketch. Now you've been given both halves mirrored over on the front plane. And as always, whenever you're going to make something mirrored, you always have to make sure that any curves that meet the mirror plane do so at a perpendicular direction to the mirror plane. So here we see horizontal handles making them perpendicular to the vertical mirror plane. Before you get started, one profile has intentionally been left as a half profile, so it will be your job to correct this to mirror over the other side, and I'll show you how to do that now. I'll edit this profile. All we have to do is take this vertical line, which is a solid line, change it to a construction line. Now just select all of our lines, mirror the entities, and that's going to mirror these lines about this construction line. That will complete that particular task. Now we're ready to go ahead and make our boundary going from tail to tip, including both halves at the same time. So selecting the first section, P1, 2, 3, 4, 5, 6, 7, complete with P8. This was added into our direction 1, and then for direction 2 we'll include our outer guide curve, top guide, which has already been provided for you in the starter, and the bottom guide, which was also provided for you. Here's our completed seat. But we look at it from the top and we see that this half is not perfectly symmetrical with this half. Even though our profiles are symmetrical, we have nothing guiding this outer edge to manage the transition from one profile to the next on the left side of our seat. This of course suggests that what we need to have is another guide curve running on this side of the seat, which is a mirror image of our original guide curve. The only problem is that this guide curve is a projected curve, and there's no way to make mirror images of projected curves. Instead, what we have to do is remake a new projected curve for this side using mirror images of the original sketches that were made to make this guide curve. The easiest way to do this is to go back to our top layout sketch and take this original curve and mirror it over to this side of the seat. This has already been done for you in the starter file. Now what we can do is use this curve when we make a new guide curve. To make the new guide curve, once again we're going to have to copy the appropriate elements from our layout sketches. On the top plane we'll start a new sketch and copy just this line from the top layout using convert entities and complete that sketch. On the front plane we'll start a new sketch and use convert entities to copy this line and finish the sketch. Now, to be safe, I'm going to hide all my layouts so I don't accidentally pick them, so I can see just this copied sketch and this copied sketch, and using Insert, Curve, Projected, I'll project these two sketches together to create my brand new outer guide curve, which is a mirror of this guide curve. And I'm just going to re-show my top guide and my bottom guide, which are both located on the front plane. Now I'm ready once again to go back and make my boundary. Starting with P1, 2, 3, 4, 5, 6, 7, and I'll select P8 from the feature tree because it's a single point, and then in direction 2 I'm going to select this outer guide curve, the top guide, the bottom guide, and this brand new guide that I created, which is a mirror image of this guide. That seemed like a little less work than the other method, and here we have a nice smooth looking boundary that represents a completely symmetrical looking seat. So why not just use this method after all? Now let me pause for just a moment and go back to the completed example file. Just reiterate that the steps that you just created were step 1, which was copying this curve from the top view, this curve from the front view. Step 3 was to make a projected sketch of the two. Step 4 was finally to create the entire boundary. Before doing any of that, you also had to correct the P2 profile sketch and make sure that this half was mirrored over to this half. Now, going back to the starter file that we were working on, the next step would be to simply shell this out. So we're going to select this bottom surface, shell, 3mm thickness. Once again, like before, we have this warning about the minimum curvature of our shell. I'm not going to worry about that. And I see that the shell wants to fail. I could keep trying to make this thinner and thinner, but it's probably going to continue to fail. The reason for this has nothing to do with the thickness of the shell, but something that we got rid of using the other methods. The problem is this, is that when we created a boundary all in one piece like this, we started with a single point at this end and finished with a point at this end. So this is back to the problem of having a degenerate point at either end of our boundary. And when we have a degenerate point, what we can have are little ripples in the boundary that make it impossible to make a shell. To solve this problem, we are going to cheat just a little bit to get rid of that degenerate point. What we're going to do is skim a tiny bit of this bottom surface off, just enough to get rid of the area that is probably rippling at this end and this end, and see if that allows us to then make our shell. To do this, we'll make a new sketch on the front plane. I'll turn on my front layout. I'm going to copy just this bottom line, again using Convert Entities. I'm going to just arbitrarily stretch this out a little bit to make sure it's well beyond the ends of the seat at either end. And I'm going to use the Offset Entities command. Set this to about 1 millimeter. Reverse it so that this offsets upward. And then what we're going to do is take this original line that was copied and change that to a construction line. We're going to use this line to slice off a little bit of the bottom of the seat. We've changed this to a construction line so that it is not used in the cut. Now 1 millimeter is too much, but I purposely set it to 1 millimeter so I could easily see the direction that the line was offsetting, whether it was offsetting downward or offsetting upward. Now that I've made my offset line, I'm going to go back and edit that dimension to something much smaller, more like 0.1 millimeters, which is about 4/1000ths of an inch. So if we look here again at a close-up, 4/1000ths of an inch is only taking a very tiny amount off of my seat and isn't going to affect the design very much. Now I can do an extruded cut using through all in both directions. That will be the default because we just have a single line cutting, this cut command. We want to make sure that it's going to cut downwards. So we're going to say flip side to cut. This is going to shave a thin little bit, 0.1 millimeters off the bottom of the seat. So it hardly looks any different. Now we're going to try shelling this again, 3 millimeters, bottom surface. We see that immediately is able to shell without a problem. And we can go ahead and add our fillet to the outside and the inside edge just like before. So this seems like a pretty attractive method, and it's probably hard to understand why we weren't using this method to start with. Some of the problems that can arise from this, first of all, are the fact that we did have to shave the bottom off. So that means we are changing our design intent just a little bit. We had a layout of a particular size, and then we're shaving 0.1 millimeter off of that layout. That's not much and probably won't affect your design, but in some extreme cases you might have to shave more off to get the shell to work. When you shave the bottom of this off, we can see that not only are we moving the edge upward, but it also means that this point is going to move in this direction at the same time due to this curvature. So that means that this seat is getting slightly shorter as a result of cutting this bottom off. That means that under some circumstances you might want to compensate for that ahead of time in your layout sketch if you know that you're going to have to do that. Now another reason that we might not want to use this technique is we cannot absolutely guarantee that this half of the boundary is exactly a mirror image of this half of the boundary. It will definitely be a mirror image at the places where profile curves occur. But the way Solidworks solves the surfacing in between profiles might be a little different on this side than on this side. If we turn on curvature, green means somewhat curved, blue means less curved, black means no curvature at all. We see that the shading looks fairly symmetrical on both sides. We do see a subtle difference in the shading here compared to this side, which means that in this area there is a subtle difference on this side of the seat compared to this side, but it's very small. However, in extreme cases, if we have a much more complicated shape, we could have cases where the way the boundary is solved over here is not the same way it's solved over here. This could give us problems down the road if we were going to create a feature on this side and then mirror it over to the other side, and maybe the way it interacts with this side will not be the same as the way it interacts with this side. Another problem with this technique is that if we plan on adding a lot more features to this model that are also supposed to be mirrored over, it means that we have to mirror each and every one of those features over individually. So you can imagine on a complicated design, which might have another 50 features, we would either have to mirror each of those 50 over individually, or we would have to have a mirror command where we have to select each of those 50 features to carefully mirror them over. This can be problematic, especially when you're trying to mirror things like fillets. It's often much easier if you know you're going to mirror a large number of items to do all of them in one half of the body and then mirror the entire body over in the end. This method is preventing us from doing that. One sneaky trick to get around that, though, is to cut the seat in half again, delete this half, add all of our features onto this side, and then when we're all ready to go, just mirror the body over again. So for example, if I use the front plane to cut away this half, and then remirror this body over, Because of this technique we used to create this in the first place, this mirrored half should join up nicely with the original half, unlike with the other techniques we were using. So we go to the zebra stripes. You see that this blends together quite nicely on the join line. So that might be a little trick you can use. We purposely build both halves at one time, cut away the second half, add all the features we need to add to this half, and then mirror the entire body over, which will include all the features that we created downstream. Just to recap the process for the tutorial, steps 1 and 2 were to copy the appropriate curves from the layout sketches. Step 3 was to project those two sketches together to create a new guide curve on the outside edge. Step 4 was to actually create the entire boundary. Step 5 was to create a sketch that offset the bottom by 0.1 millimeters and use that sketch to skim off the bottom. Step 6 then was just to shell the entire boundary with a 3 millimeter thickness. Step 7 was to add the 1 millimeter fillets on the edges like before.